James Webb Space Telescope and aliens. QURO, French Guiana, behind glass, sealed inside a clean room. The James Webb Space Telescope looks like a museum exhibit, an artifact meant to be preserved and revered. Yet its journey has hardly begun. An army of technicians is preparing the telescope for its upcoming million-mile voyage into space, where the observatory's golden honeycomb eye will gaze back in time, peering at the earliest beginnings of planets, stars, and galaxies. For now that 21-foot wide eye is closed, the telescope folded like a clamshell. Gleaming in shades of gold, silver, and crinkled lavender, the $10 billion instrument is too big to fit inside one of the world's biggest rockets, the Ariane 5, without being folded up. NASA is footing the bulk of the mission's bill, but the European Space Agency, which contributed to 2 of the 4 onboard science instruments, is responsible for launching the telescope. That's why, as soon as December 24, JWST is slated to take flight from ESA's tropical spaceport in French Guiana. In the case of JWST, the vibrant landscapes surrounding the complex serve as a reminder of the Space Telescope's mission to help scientists understand how we got here. From the tangle of molecules, stars, galaxies, black holes, and planets that populate the universe, the ingredients necessary for life emerged and combined to make this place called Earth. Are the conditions that favored this thriving, noisy biosphere common among the millions, or perhaps billions, of rocky planets populating the galaxy? To search for answers, JWST will observe hundreds, maybe thousands of exoplanets before its mission is done. It will stare at hellish lava worlds with molten surfaces that whip around their stars in mere hours. It will study worlds that somehow survived the violent deaths of their stars and now orbit their leftover stellar corpses. It will gaze through the atmospheres of gas giant planets, search for newborn worlds among the dusty disks that cling to infant stars, and squint at a handful of small, rocky worlds that just might be similar to Earth. Of the thousands of exoplanets we've seen in our galaxy, only a handful resemble the planets we see in our own solar system. The rest are undeniably alien. One of the greatest discoveries that we've made within the field of exoplanets is that the diversity of planets within the galaxy is just so much greater than the diversity of planets in our own solar system, says Natasha Batalha of NASA's Ames Research Center. We want to understand the process that led Earth to having a habitable environment. Is the fact that we have liquid water oceans and oxygen, is that unique? Or is that fairly common within the galaxy, the Milky Way's many planets? Like many of humankind's most ambitious science and engineering projects, JWST's journey to the launch pad has been mired in technical delays and ballooning budgets. More recently, a controversy erupted over the telescope's name. But if everything goes to plan, this flagship telescope, considered the successor to the venerable Hubble Space Telescope, should deliver a cornucopia of scientific delights. JWST will see the universe primarily in infrared light. Once its hulking golden eye opens, the observatory's exquisite sensitivity will allow the telescope to spy the faint, faraway signatures of the first stars and galaxies that populated the universe. That sensitivity will also help it directly observe alien worlds, though nobody could have planned to use the telescope for this purpose when it was designed. When JWST was conceived in 1989, planets orbiting other stars had not yet been discovered. Planet formation theories suggested such worlds should exist, but the first exoplanets weren't announced until 1992. In the beginning, when the observatory was born, I don't think we even spoke about exoplanets, Jensen says. Exoplanets came later, when we started discovering there were actually exoplanets. Dissecting planetary atmospheres. About 6 months after arriving in space, JWST will begin drinking in starlight and studying faraway worlds. As planets pass between their stars and the telescope, for a brief moment, their atmospheres will appear in silhouette, illuminated by the starlight shining through from behind. In that starlight, Webb will read the signatures of the gases the light passed through. A grab bag of extreme systems and planetary oddballs are among Webb's early transiting targets, including WD 1856 bits, a giant planet that orbits a stellar corpse, and HD 80,606 bits, a planet whose orbit looks more like a comet's elongated, lopsided loop around its star than a planet's more circular path. Those extreme systems could contain clues about how different kinds of planets form and survive, Colon says. Taking pictures of planets. Not all of JWST's planetary targets transit their parent stars. Some trace orbits hundreds of times farther from their star than Earth is from the Sun, circling in systems that we can see from the top down or bottom up. A portion of the early exoplanet observations will directly image planets in these kinds of systems by blocking out the host star, although the planets will just look like small pricks of light in the images. Most of these observations will target large planets, gas giants, and maybe ice giants that are very far from their stars, and therefore easier to spot when the star's light is erased. Such observations will let scientists learn more about the structures of atmospheres, the types and amounts of clouds that might exist, and the relative amounts of molecules, such as methane and carbon monoxide, that can point to a planet's birthplace. The long search for life. While JWST will transform our understanding of the worlds that populate our galaxy, the telescope is unlikely to spot signs of life, unless scientists are extremely lucky. That type of observation is just on the edge of the telescope's capabilities, and it would require an oversized chunk of observing time. Finding life is going to be hard, and I'm not super confident that we will detect biosignatures, but I think we will be able to say something about the atmospheres of these planets around small stars, says Kevin Stevenson of the Johns Hopkins Applied Physics Laboratory, who will observe 5 rocky planets with JWST. The U.S. National Aeronautics and Space Administration, NASA, led JWST's development in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA. The NASA Goddard Space Flight Center, GSFC, in Maryland managed telescope development. The Space Telescope Science Institute in Baltimore, on the Homewood campus of Johns Hopkins University, operates JWST, and the prime contractor was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. The James Webb Space Telescope was launched on 25 December 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first image from JWST was released to the public via a press conference on 11 July 2022. The telescope is the successor of the Hubble as NASA's flagship mission in astrophysics. JWST's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combined create a 6.5-meter diameter, 21 feet, mirror, compared with Hubble's 2.4 meters, 7 feet 10 in. This gives JWST a light collecting area of about 25 square meters, about 6 times that of Hubble. Unlike Hubble, which observes in the near ultraviolet and visible 0.1 to 0.8 millimeters, and near infrared 0.8 to 2.5 mm10 spectra, JWST observes in a lower frequency range, from long wavelength visible light, red, through mid-infrared, 0.6 to 28.3 mm. The telescope must be kept extremely cold, below 50 K, minus 223 degrees Celsius, minus 370 degrees Fahrenheit, such that the infrared light emitted by the telescope itself does not interfere with the collected light. It is deployed in a solar orbit near the Sun-Earth L2 Lagrange point, about 1.5 million kilometers, 930,000 miles, from Earth, where its 5-layer sunshield protects it from warming by the Sun, Earth, and Moon.